TK News, where we always update you about the latest trending topics. We also make complicated topics very simple to understand. Last Friday, on 2nd July 2021, a loud boom was heard in several areas of South Bangalore. Along with the boom, heavy vibrations were felt and some people reported that their window panes rattled. In May last year, a similar boom was heard and the Indian Airforce admitted that it was caused by a test flight involving a supersonic profile. Supersonic? Supersonic means speed greater than the speed of sound, and the boom, it was a sonic boom. This year as well, people suspect that it was a sonic boom, but there were no admissions forthcoming this time. Sonic boom happens due to sound from an object that flies faster than sound. Normally, it is flight of planes or rockets that could fly faster than sound. But we have all heard planes before, right? It is a loud, high-pitched, constant sound, but it's not a boom. But here, it is the aeroplane, but the sound was a boom. How is that? Let's find out. First thing to understand is how sound travels. When a sound is made, a vibration is created at the source. These vibrations move the air molecules around the source and the air molecules also vibrate. This air molecule vibrates the air molecule next to it and that air molecule vibrates the air molecules next to it and this goes on. This vibration then travels in air and it hits your eardrum. Your eardrum also vibrates at the same frequency due to the air hitting your eardrum. This vibration is then understood by your brain. That's how my neighbor knows and says, "God, Pranav has started practicing drums again." I'm still gonna do it. Since air is invisible, you cannot see the waves propagating in air. But you can always see how the wave propagates in water to understand. Look at this quite serene lake. Now let's throw a stone in the middle of the lake. There it is. You will see a circle come out and then another circle and then another. And if the stone made a big impact on the waves, it can even reach the shore or it will die out somewhere in between. If you keep on throwing stones into the lake, new circles will be formed and on the bank you will get one wave after another like you are on a seashore. Now, let's look at a speedboat traveling in this lake. Here the difference is, the boat which is making the waves is itself moving. Here the wave starts as a circle, but since the boat is faster than this wave, it hits the wave, breaks it. Like this, it breaks several waves and instead of a circle, it forms something like a triangle with the boat at the tip of the triangle. As the boat moves ahead, the waves are created behind it. The person relaxing on the shore does not see the wave when the boat passes. It is only after the boat has went further ahead, the waves from the boat hit the shore and surprise the person relaxing on the shore. A big wave because the boat broke several smaller waves ahead of it and they together hit the shore. Something similar happens with the sound of an aeroplane in the air. When we make sound in the air, the sound travels in all directions like the wave we saw on the lake. But if the source of the sound is moving like the boat, what will happen? That's a good question. Let's look at this bike which makes the phat sound as it moves. When this phatphati, as we call in India, makes the first phat, a wave is created. But by the time the next phat is generated, the phatphati has moved forward like the boat. The wave in front of the bike from the next phat now looks closer to the wave from the first phat, but wave behind the bike looks more far to each other. And then the third and then the fourth wave and so on is emitted. See the waves in the front? They look compressed, and the waves in the back, they look far away. So anyone listening to the sound of this phatphati from the front will hear a loud phat sound when it is arriving due to the compressed waves, and later it recedes instantly as it passes. That is because the waves behind the phatphati is distant from each other, and so the sound is weak. Now you can relate to the sound of the train siren from the fast train as you wait on the level crossing, or sound of a car when you are watching a cross-country race, or the sound of my favorite Lightning McQueen in the movie Cars. In physics, we call this compression of sound waves the Doppler effect. But in reality, it is just this phatphati effect we just saw. Just a more fancy name. Sorry, no offense meant to Austrian mathematician and physicist Christian Johann Doppler, who found this way back in 1842 when he did not even have an internet. Hats off to Christian Johann Doppler. Now, we know why sound of approaching vehicles sound louder, but we still do not understand the boom. The sonic boom. Here, speed of the moving object comes into picture. We earlier saw that sound propagates, so it has a speed. It moves at 343 meters per second, or 1, 2, 3, 4 kilometers per hour. That's easy to remember. Obviously, my phatphati goes very slow, much slower than the sound. Now let's assume my phatphati gained wings and can fly and can travel very fast, equal to or more than the speed of sound. Now let's see what happens to the sound. When my phatphati moves at the speed of sound, all the phatphats are concentrated at position of my phatphati. A person standing at the front of the phatphati will not hear anything till it reaches the person, and then suddenly he will hear all the accumulated sound. While I am riding the bike, I will have to cover my ear with something like this when I ride, and also when I play drums so that my neighbors will hear but not me. And also when my mother scolds me. What did you say? I can't hear you. What? Huh? When my phatphati moves faster than the speed of sound, my phatphati is ahead of the phat sound. The phat waves start falling behind and starts growing like the waves on the surface of the lake, but behind the phatphati. So as a rider, I will not hear anything as I am traveling faster than my phat sound. The wave from my first phat goes behind and it starts growing behind my bike. Then the next phat comes and it grows, but will be a little smaller and just behind the earlier phat. Then the next phat and then the next, and it goes on. This set of phats will form a cone behind my bike. Since the bike is high up in the air, the phat waves take a while to grow and reach the ground. So a person standing right under my flying bike will not hear anything. He hears it much later when the phat sound waves travel and reaches the person on the ground. But when he suddenly hears the compressed set of waves as a boom. Now picture a fighter aircraft instead of my phatphati. It makes a very loud continuous sound instead of the phat when it travels in the air. Most of these fighter aircrafts are supersonic, which means it can travel faster than sound, and when it does, it can cause a sonic boom. This compressed set of waves carries so much energy in them that it can rattle window panes and sometimes even damage some weak buildings. So normally, these flights don't fly over land, they fly over the oceans. But sometimes they do fly on land and cause sonic booms like we experienced in South Bangalore. Other than fighter aircraft, Concorde was a commercial aircraft that flew at supersonic speeds. It flew between Paris and New York and London and New York, and it used to fly at supersonic speeds only over the Atlantic Ocean. It could fly at 2172 km per hour, while a Boeing 747 could travel only at 988 km per hour. Concorde aircraft was discontinued in 2003 after a crash killed 113 people. There are sonic booms other than fighter and commercial airlines. The cracking of a whip is a sonic boom created when the tip travels faster than sound. Diplodocus, a dinosaur, was believed to crack its tail at supersonic speeds like a whip to fight its enemies. So the Diplodocus probably used to whip T-Rex with its tail. There are other sonic booms in nature. Pistol shrimp can shoot its prey by snapping its claw at supersonic speeds. There is one sonic boom in nature that all of us have heard. Can you guess what that is? Yes, it's the thunder. The lightning forces the air to move faster than the speed of sound, causing a sonic boom, which we all know as thunder. Hope you liked this video. Then please hit the subscribe button and then I will notify you when I add my next video. Ta-ta! Bye-bye! See you!